Pre-treatment units design. Pre-treatment units design are always designed based on the flow of the last phase, which is the flow at the end of design period. So in this cell, the equation will be like this: equals, and go to the previous sheet and press this cell and press enter. So the name of this cell, the name of the previous sheet, population and flow, and the name of the cell at that sheet, and convert this figure to the other units like these cells. To convert the flow to cubic meter per hour, we can write this equation: equals this cell divided by 24 hours. We get this figure, and this cell, we can convert this figure to liter per second like this: equals this cell times 1000 to convert to liter divided by 24 times 60 times 60 to convert to second. We get this figure. We can get the flow by cubic meter per second by divide this cell by 1000. Peak factor, here we use 3. You can use any value from this range, 2 to 3. And after that we calculate peak flow QF. QF equals Q average times peak factor. And this cell times peak factor. And so on. BOD at inlet S naught assumed 700. Suspended solids at inlet SS assumed 200. Final outlet BOD, required BOD at the end of sewage treatment plant 20 milligram per liter, and required final outlet suspended solids 30 milligram per liter. First unit of pre-treatment units is inlet chamber or receiving chamber. The purpose of providing inlet chamber is to reduce the velocity of sewage so as to achieve better efficiency in screening. Peak design flow QF equals this cell. So this is peak flow for the design. Detention time assumed 30 seconds, minimum 30 seconds at peak flow. Volume of inlet chamber is calculated as this: equals the peak flow times detention time, 1.09 cubic meter, because volume equals Q times T. Assume side water depth 0.7 meter. Surface area of inlet chamber equals the volume divided by the water depth. So this cell equals volume divided by water depth. This is the surface area of inlet chamber. If we assume width of inlet chamber 1 meter, so the required total length of the inlet chamber equals surface area, this cell, divided by inlet chamber width, equals 1.56. Say 1.6 meter. Assume free board equals 0.5 meter, so total depth equals water depth in the inlet chamber plus free board. So equals this cell, water depth plus free board, this cell, enter, equals 1.2 meter, because total depth of inlet chamber equals water depth plus free board. This is the cross-sectional area of inlet chamber. This is the free board 0.5, and this is the water depth 0.7, and the width is 1 meter. This is the sewage inlet, and here sewage to screening. The inlet chamber can be straight or as curved like this in this picture.